Well, good morning, good afternoon, or good evening, everybody. Welcome to class. It's good to have you here. Let's do a quick warm up just to make sure we're feeling okay about what we were just doing. So let's take a quick look at our warm up here. I would like you to factor these expressions completely, okay? Factor these expressions completely, all right? So I want you to take, let's say, about 5 minutes to work on this, but you can pause the video and then work on these and then unpause when you're ready, okay? So I'm going to wait for 1 minute before we continue, but if you're not finished by then, you're more than welcome to pause the video, finish working on them, and then we'll look at them as a class, okay? So take 5 minutes or so. Okay, if you're not quite done with that, which I can't imagine most of us are, go ahead and pause that, okay? Let's go ahead and pause that and finish work on that. And here we go. All right, so the art of factoring is figuring out the highest number that can go into all of the terms. Like I'm looking at 15, 10, 20, and 5, and my instinct goes right to 5. So we're going to put a 5 on the outside, and then we're going to say what would be on the inside so that when I multiply through, it would make all these. Like 5 times something is 15x. That's got to be 3x. 5 times something is a negative 10y, so that's a minus 2y. 5 times something is a plus 20z, so that's got to be a plus 4z. And 5 times something is negative 5, so that's got to be a minus 1. That's how we do that. We do the distributive property in reverse like that, okay? Now over here, it's a little bit tricky. Like I'm looking at these numbers, and honestly, the only number I'm very sure goes into all of those is 2. I can see 2 goes into all those numbers. So I'm going to factor out a 2. And that's going to be 27a plus 21b plus, minus 39c plus 18d minus 51. Now there's actually a number that goes into all of these. You'll notice there's a 3, a 3, a 3, a 3, and a 3. And if you're not sure, you can just try to divide each of these in 3 by 3 and see if anything nice happens. So we can change that to 3 times 2, open parentheses, 3 times 9a would give me 27, plus 7b minus 13c, well that's a dead giveaway, plus 6d minus 9. No. 51 divided by 3 goes in once. Oops, yeah, I'm way off. Okay, hang on. So that's a 3 minus 21, 17. My goodness gracious, yeah. Not 9, 17. Excellent. So that's how we're going to do that. But then, of course, the 3 times new needs to become 6. So the final answer is 6, open parentheses, 9a plus 7b minus 13c plus 6d minus 17. Voila, c'est fini. Now this last one, we talked a little bit about this on one of the days that I was gone, but let's talk about it. So if we factor out of that 3, which we can see 3, 6, 12, 9, that's going to give us x plus 2a minus 4s plus 3a. 3a, yeah. Now, I want you to notice that these actually do still have a factor in common, that even though that's a variable, that still counts as a factor. So in order for this to be fully factored, I can actually factor out a 3 and an a. leaving behind x plus 2y minus 4z plus 3, and that's how as far as we can go. Okay, let's go ahead and talk about our what we're up to today. So if you'll turn to page 55 in your in your planner, turn to page 55 in your planner. Did you guys know that 55 is the highest Fibonacci number that is also a triangular number? Yeah, it's true. So our essential question today is, what is an equation and how do I set up and solve one? Well, let's find out. So underneath your warm-up, got a pencil? Perfect. We're going to do equations introduction. All right, let's go ahead and get started. Oh, I didn't actually open it up. Mr. Petersen, tut, tut, tut. Now I don't want to move it. I want to download it. Oh my goodness. You guys are seeing how the sausage is made now. Okay, let's see here. I have to do file. Yes, I understand you're loading the presentation. You know what? I wonder if I can present it like this. I think I can. Oh, good, I can. Maybe. Okay, one step equation setup. Let's get to it. Drones. Did you hear about this, guys? Holland has trained eagles to fly around secure areas and destroy drones. I absolutely love this idea. The idea is that there were people who were flying drones over like prisons and like dropping things they weren't supposed to prisoners. They were flying them over like government installations and taking pictures. And so they actually trained these eagles to attack drones because they train like they would fly drones around with little bags of meat tied to their feet. And so when eagles would attack them, they would think that they had delicious bags of meat on them. And so now eagles fly around Holland, and if you fly a drone that is too close to a secure area, it will attempt to eat your drone, which I think is the coolest thing ever. And if we don't have these in America, I feel like, why do we not have this? Anyway, suppose that a drone takes off and an eagle follows it, traveling at the same speed but 7 meters behind it. Let's answer these questions. If the drone's traveled 10 meters, how far has the eagle traveled? So remember, the eagle is 7 meters behind it. So it's going to be 17 or it's going to be 3. Which one is it? Which one is going to be 7 meters behind the drone? Something that is has gone 3 meters or something that's gone 17? Yeah, it's 3 meters because the eagle is behind the drone. Eagles are greater than drones. This is so cool, you guys. What if the drone's gone 13 meters? Remember, the eagle is always 7 meters behind. So if the drone's gone 13 meters, then the eagle's gone 6 meters, right? Because 13, 12, 11, 10, 9, 8, 7, 6. What if the drone's traveled 27 meters? How far is the eagle gone? Yeah, 20 meters. Let's write an Al-Khwarizmi equation showing how far the eagle has traveled based on how far the drone has traveled. Let's write that down. Got a pencil? Okay, so we know that we can keep track of that because when I tell you the distance the drone has traveled, the distance the drone has gone, you subtract 7 from that, and that tells you how far that the eagle has gone. Now, I don't know if you guys have been feeling this, but I find that a lot of students, when we're learning this expression stuff, these feel empty, and a lot of us actually put a little equal sign right there, almost because we're just like begging for this to be a full sentence. It's the distance the drone has gone minus 7 is, well, it's how far the eagle's gone. And the thing is we can actually use algorithmic style equation to show that. So instead of just leaving it as the distance the drone has gone minus 7, we're actually going to say that the distance the drone has gone minus 7 is equal to the distance the eagle has gone. Okay, go ahead and write that down. That's the Al-Khwarizmi style equation that keeps track of how far the drone has gone. Or sorry, how far the eagle's gone when I give you the drone. Let's go ahead and make this modern style. So the distance the drone has gone, I guess I'll use D. So we're going to use a capital D. If I take the distance the drone has gone and subtract 7, that's going to give us the distance the eagle has gone, which I'm going to call capital E. So part of the reason we write these equations is that when I'm giving you these distance that the drone has gone, we're actually replacing the D with that distance. So when I said, if the drone's gone 10, how far has the eagle gone? Whether you realize you did it or not, your brain actually replaced the D with 10, took 7 away from it, said it was equal to 3, and that was equal to E. So we knew that E was equal to 3. When I said the drone's gone 13, your brain took 7 away from it. 13 minus 7 is 6, and that was the distance the eagle's gone. When I said that the drone has gone 27, your brain took 7 away from 27 and found out that the eagle has gone 20 meters. Whether you realize it or not, your brain is doing this stuff that I'm showing you here to the right. And the whole point of studying equations in 7th grade is to get us to slow down our own thinking and figure out what is happening here. What is our brain doing with this information, and how can we put that onto the page here? Excuse me. Oh, it's going to make me start at the beginning, but I guess I can look at these sweet, sweet eagle pictures again. So cool. I seriously can't get enough of this. It is like the coolest thing ever. So I've got another question for you. What if the eagle has traveled 10 meters? How far has the drone traveled? Because remember, when the drone went 10, the eagle had gone 3. So if I say that the eagle's gone 10, how far has the drone traveled? Right, the drone's gone 7 more meters than the eagle, so that means that the drone has actually gone 17. What if it's gone 16 meters? The eagle, I mean. What if the eagle has gone 16 meters? Yeah, the drone's gone 7 meters more than that. That's going to be 23, I think. No. Yes, 23, 16, 17, 18, 19, 20, 23 meters. And if the eagle traveled 98 meters, yeah, the drone's gone 105. So let's take a look at what is happening when we're saying that. So when I say that the eagle has gone 10 meters, our equation in our head looks like this. We know that the drone distance minus 7 is equal to the eagle distance. That's what we came up with over here. And when I tell you that the eagle distance is 10, your brain replaces it with 10. Now you came up with the drone distance is equal to 17. And the whole purpose of this lesson and the whole purpose of studying equations in 7th grade is to be able to tell another person, someone who doesn't live inside of your head, what did you do with this number and this number to create this number? Will you guys go ahead and if find someone who's got to the same point or wait for them to get to this point, then I want you guys to talk to each other. What did you do with these two numbers, the 7 and the 10, in order to make a 17? Go ahead and talk to each other about that. I'll give you guys 45 seconds. Helicopter flying overhead at 9:15 at night, I say. Better be important, my friend. Probably is. Don't think anyone's joyriding 9:15 in the rain. I think it's raining. Maybe it's only just it has rained. Anyway, did you get it? What did we do with 7 and 10 to create a 17? Well, we added 7. And the point of this lesson and the point of how we study this in 7th grade is to make sure we understand that we can actually write that I did 10 plus 7 and that equals 17. But where did the minus 7 go over here? So what we're going to do is, in order to do this, we have to actually create what's called balance. It's kind of like a scale. You know what I'm talking about? Like one of those old-timey scales where there's like a bowl over here, like a bowl over here. I imagine that this side has 10 and this side has d minus 7. Now, I want you to notice that if I were to add 7 over here, this bowl would go down, right? It would be out of balance. So to create balance, I have to add 7 to this side too. That's how I actually got rid of that minus 7, because a negative 7 plus 7 is 0. So that turns into d plus 0, and that becomes 17. This is how we show somebody what we're thinking. This is how we can show somebody, well, I added 7 to 10 to create 17, and I could do that because in order to get rid of a minus 7, I had to add 7 to it. On a similar token, I think I asked you also about when the eagle's gone 16. So that would be, again, the distance the drone has gone minus 7 is equal to 16. Now, I would look at that and say, I need to get rid of this minus 7 because I want to know what d is. I need that d to be by itself. To get rid of a minus 7, I'm going to add 7. The reason that works, by the way, is because if that says d minus 7 plus 7, if I combine these like terms, negative 7 plus 7, I get d plus 0, but anything plus 0 is itself. So that gets my d to be by itself. But I have to create balance in this equation, so I have to add 7 over here as well. So 16 plus 7 is 23. Yeah, we went over that, 23. So that the whole time was equal to 23. Now, I don't expect you to write this entire mess. What was the last one? It was 98 meters. So if I said that d minus 7 was equal to 98, here's what I'm expecting from you on a skill check. But you see that minus 7 and you realize we need to get rid of a minus 7 by adding 7 to it. A negative 7 plus 7 eliminates it. That's the whole purpose of doing that. And then 98 plus 7 is 105. This is how you get a 3 on your skill check. And it's actually a 4 if you can apply it to a story, like our eagle story here. So if there's no like if it's just flying out in space though, like let's go ahead and think of this one. What about y minus 9 equals 13? This is saying what number, when you subtract 9 from it, is equal to 13. And we do that because of opposites and balance. We can use opposites to eliminate that minus 9 to find out what y is, because that's what we want to know. What's y? If I add 9 to negative 9, it'll be gone. But our scale will be out of balance, right? This side has too much on it because I added 9 to that side. So I have to add 9 to this side also. And 13 plus 9 is 21. This is really helpful when the answer isn't really that obvious. Like, what if I said that z minus 13 is equal to negative 29? Well, I have this tool, with this tool at my disposal, knowing that I can get rid of a minus 13 by doing a plus 13, and then I just need to create balance, I can plug that in my calculator, negative 29 plus 13, and I get z equals negative 16. One more thing to talk about. And we've been writing this all down, right? Like if I come and check on that on Monday, you have written it down. How about this guy? A plus 5 equals 22. I'm telling you that if I have a mystery number and I add 5 to it, I'm going to get 22. What is that number? What number could I add 5 to get 22? Did you say 17? That would be right, and here's why. The key to solving an equation, any equation, is by using opposites and balance. Well, not any linear equation is using opposites and balance. The opposite of plus is minus. So if I subtract 5 from here, I will get rid of that and be left only with A. To create balance, I must subtract 5 as well. So that bar is there, 12, 11, 10, 9, 8, 7, 1, 17. A equals 17. So opposites tell us what to do, and balance makes us do it to the other side. It works if it's on this side too. 3 plus 7, yeah, 3 plus 7 is 10. 3 plus B equals 13. So 3 plus what number is 13? Now I know what you're thinking. How do I get rid of this plus sign? I can't get rid of that B. It turns out you can, but that's kind of complicated. The truth is that we use subtraction because if we get rid of a positive, there's a secret plus here. Get rid of a positive 3 by subtracting 3. That'll leave plus B, but without that plus, it'll just be positive B. To create balance, I subtract 3 over here as well. I subtract 3 over here. Too many 3's. And I'm left with B equals 10. Okay? That's the idea behind solving equations. Now, there's something I want you to think about over the weekend, okay? I want you guys to think about this. What if it was 3 minus B equals 13? If I subtract that 3 from both sides, I don't get B equals 10 anymore. I get the opposite of B equals 10. What does that mean B is? But we'll leave that for another day. Thanks for tuning in, guys. I hope that you had an all right week. I know I wasn't there for a lot of it. I'm going to be missing one day next week. I don't know which one, but I'll be missing at least one, I think. And yeah, so I'll be there either on Monday or Tuesday, okay? So in the meantime, keep being awesome. Thank you so much for your attention. Have an excellent weekend.